Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 314. Please turn to it. Page number 314, and today is our lesson number 31. Let's take a look at the very first problem on the page. Page 314, problem number 42. Problem number 42 says, what is the matrix product of these two matrices? The first one is A, 2A, 3A, and second one is 1, 0, and negative 1. They simply want to know if you know how to multiply your matrices. That's all it is. Now when we're multiplying matrices, we have to understand that when you're multiplying one matrix by another, the product is always equal to the product of two matrices always equal to row times column. You have to take the row of first matrix and multiply it by the column of the other one, second one. And that's how it's always done. I don't know about you, but perhaps you already know this, perhaps you have no problem remembering it. But I sometimes forget this thing. I have trouble remembering this part here. So there's a mnemonic that I use, and the mnemonic that I use is mnemonic, of course, as we know, is a memory device. Mnemonics are some things that you make up to remember something. Now this mnemonic that I'm going to share with you, I'm not sure if you're going to understand it because you're probably too young. I'm not sure if this product still exists or not. But back in the old days when I was young, we used to drink what was known as RC Cola. RC Cola, and our teacher, my teacher, math teacher, told us to remember just this part, RC Cola, row times column, you see? Row times column. Just remember RC Cola. This thing is presented in the column format. The first matrix is presented in the column format. The second matrix that is given to us is presented in the row format, and that is done on purpose. We have to be quick enough to realize that in order for us to be able to multiply these two matrices, we have to write the second one first. The second matrix has to be written first. 1, 0, negative 1, and then the other one, which is, oh sorry, what the hell am I doing? It is in the row format, row times column. 1, 0, negative 1, and then the column, which is A times 2A times 3A. And now we are done, that's it. All we have to do is just do row times column, which we're going to do it here. Okay, now follow my head. So it's row times column. So first we do we do 1 times the entire column. So it's going to be 1 times A, just like that. And then 1 times 2A, 1 times 2A. You see, row times column. So you take the first guy from the first row here. There's only one row here, but if we had more rows, we would have done the same thing. We would have repeated the procedure. So it's 1 times this entire column. 1 times A, 1 times 2A, 1 times 3A. That's it, we're done with 1. Now we do the 0 times this entire column. And of course 0 times anything is 0, it's just going to be 0, but I'm going to write it anyway. So it's going to be 0 times A, 0 times 2A, 0 times 3A, and of course it's all going to be 0. And then we have negative 1. So now we do negative 1 times A, negative 1 times 2A, negative 1 times 3A. Negative 1 times A, negative 1 times 2A, and negative 1 times 3A. That's it, we are done. We just have to simplify it, and that's our answer. We just have to simplify it, and when we do that, we find that it is equal to 1 times A is just A, 1 times 2A is 2A, then we have 3A. This entire column is 0 because 0 times anything is 0. So it's just 0. Well, let's line them up properly so we can see them actually nicely. So this is 0, second column is 0, and the third column we're going to have the same as the first column, except because it was multiplied by negative 1, it's just everything is negative. So we have negative A, negative 2a, and negative 3a. And there we go, that's our answer. A, 2a, 3a, 0, 0, 0, negative a, negative 2a, negative 3a, and that's going to be answer choice F. And that's how we multiply our matrices. I understand you probably already know all of this thing, and it wasn't necessary, but I thought I will take my time and do the proper job of it in the event that it's been a while since you did it and you might have forgotten it. So it doesn't hurt to take some time. Give me just 5 seconds. Let's do the next one, shall we? In the next one, we are given a straight line, and we are told that this angle is 2x and this angle is 4x plus 6. This angle right here is 4x plus 6, and the question is, pay attention as to what is the question asking, because otherwise, if you don't pay attention to how the question is phrased, you will find that at least 2 or 3 answer choices, at least 2 or 3 questions on the exam, you're going to blow them just because you weren't careful, you weren't paying attention as to what is being asked. Don't be presumptuous. Don't make assumption as to what is being asked here. What they're asking here is this. What they're asking here is what is the degree measure of the smaller angle. On the smaller angle, this is a larger angle because it's 4. First of all, it's 4 times the amount plus the 6, and this is 2 times the amount. They're looking for this amount. They're looking for the degree measure of the small angle. The small angle is 2x. We're not looking for the value of x. If you find the value of x, if you end up wasting your time trying to find the value of x, you're going to end up picking the wrong answer. You're going to end up picking the answer choice, which is half of the correct answer. We have to find 2x. So let's do this, shall we? We need the room, obviously. And of course we know that the sum of the angles in a straight line is 180. So it's very simple. This is 4x plus 6. 4x plus 6 plus 2x has to be 180 because it makes a straight line. The straight line is half a circle, which is 180 degrees. The straight line makes half a circle, which is 180 degrees. Now we are interested in the value of 2x. Remember that we are interested in the value of 2x. So we're not going to waste our time trying to find out the value of x and then multiply it by 2. Why should we find out the value of x and then multiply the answer by 2 when we can find out the value of 2x directly? It's right here. So that's our unknown. This is our unknown quantity. So let's subtract 6 from both sides. Let's subtract 6 from both sides. So that 6 drops out. And we end up with 4x plus 2x, which is 6x, equals 180 minus 6. 180 minus 6 is going to be 174. Divide both sides by 3. That's it. Divide both sides by 3. Why 3? Because if we divide both sides by 3, then these 3 will cancel out with the 6 and giving us 2x. You see? Now that's our unknown. That's it. We are interested in the 2x. Question is 174? The question is 174 divisible by 3? Is 174 divisible by 3? How do we know that? How do we know if a number is divisible by 3? Well, we have talked about it many a times, in the other videos. And the way we know is that if the sum, S-U-M, sum of the digits, if the sum of the digits is divisible by 3, then the number itself is divisible by 3. So let's find out the sum of the digits, shall we? 1 plus 7 is 8, 8 plus 4 is 12. 12 is divisible by 3, so 174 is divisible by 3. Of course it will have to be divisible by 3 because if you look at the answer choices, they are all whole numbers. Obviously it has to be divisible by 3, we're going to divide it right here. 174 divided by 3. How many 3's in a 1? 1 has no 3's. 1 has no 3, that 1 is going to go and join the 7, it's going to become 17. How many 3's in a 17? 17 has 5 3's. 5 3's are 15. 5 3's, this is how we say it. 5 3's are 15. That's how we speak. 5 3's are 15. So cross out the 17, we put down 5, but we have a remaining 2. This is 17. We have a remaining 2. The remainder of 2. Not remaining 2. We have a remainder of 2. That 2 goes and joins this 4 and becomes 24. How many 3's in it? 24. 24 has 8 3's. 8 3's are 24. 8 3's are 24. I was about to say 6, but 6 3's are 18. 8 3's are 24. That's it. That's our answer. It's 58. 58. 2x equals 58, and that's what we're looking for. And of course, you can pretty much bet that if you were to divide both sides by 2, whatever we end up here, half of 50 is 25, and half of 8 is 3. Half of 8 is 4. 25 plus 4 is 29. I bet you 29 is one of the answer choices. Yes, 29 is one of the answer choices, right above 58. But that will be wrong. They're looking for what's the degree measure of the smaller angle. The smaller angle here is 2x. That's all. The answer is 58. Let's move on then to the next problem. Number 44. It says, how many prime numbers are there? How many prime numbers are there between 30 and 50? How many prime numbers are there between 30 and 50? Well, the first thing we have to understand is that in order for a number to be a prime number, it has to be, first of all, an odd number. An even number cannot be a prime number, with only one exception. 2 is the only even number that's a prime number. 2 is the only even. By the way, what I would like you to do, if you want to get a little bit more into it, and if you want to learn the concept of prime number thoroughly, because here they're simply asking for from 30 to 50, but you should know your prime numbers all the way from 1 through 100. You should know those. You shouldn't have trouble trying to locate a prime number between 1 and 100. They come in quite handy in the exam. Well, I would like you to watch this video. Just type in revised GRE, day 79. I know we're not here for the GRE. We are here for the ACT. The reason the ACT is not listed here because I didn't have the forethought of buying the domain name for the ACT. So I do not own that domain name. It belongs to somebody else. Prep for ACT is not mine, but all of these domain names, if you type in any of those domain names, it will take you to our website, which is keshwaniprep.com. Anyway, revised. I understand that we are not here for the GRE. We are here for the ACT. But the concept of prime number is the concept of prime number. It doesn't change with the exam. Do you understand? It doesn't change from exam to exam. So if you're interested in learning your prime numbers from 1 through 100, just type in this tag. Revised GRE day 79. Or at any time you want to learn anything about any particular concept in math, just type in the name of the concept. Just type in prime numbers and then type in my name. Just type in prime numbers and then type in Keshwani, and then out come several videos that you can watch. But here you're going to end up having to deal with more than one video. This is one specific video where I talked about the prime numbers from 1 through 100. Anyway, enough of the talk. So the first thing we have to understand is that in order for it to be a prime number, it has to be an odd number. So what I'm going to do is list all the odd numbers between 30 and 50 and then try to find how many of them are prime numbers. So let's do that, shall we? 31, 33, 35, 37, 39, 41, 43, 45, 47, and 49. Let's begin with 31. We can't divide 31. We can't divide 31 by 2. Why can't we divide 31 by 2? Obviously, it's an odd number. They're all odd numbers. So we're not going to worry about 2, but we have to list 2. In other words, we're trying to figure out if 31 is a prime number or not. And how do we figure out if a given number is a prime number? It's very simple. You start dividing that number by all the prime numbers beginning with 2, if it's an even number. The next prime number is 3. Is 31 divisible by 3? Obviously not. 30 is divisible by 3. 31 is not divisible by 3. Because it's such a small number, we can just tell by looking at it. But had it been a large number, it's very simple. Had it been a large number, for example, is 3,131 divisible by 3? The answer is no. Because that's 4 plus 4 is 8. The sum of the digits. The sum of the digits is 8. And 8 is not divisible by 3. And therefore 3,131 is not divisible by 3. Neither is 3,113. Neither is 1,000 because the sum of the digit is not divisible by 3. 31 is not divisible by 3. Let's move on to 5. Is 31 divisible by 5? The answer is no, because in order for a number to be divisible by 5, it has to end in a 0 or a 5. The next prime number is 7. Is 31 divisible by 7? The answer is no, because we know that 7 4s are 28 and 7 5s are 35. This one falls between 28 and 35. It is not divisible by 7. We don't have to worry about 9. 9 is not a prime number. Next one is 11. Is 31 divisible by 11? The answer is no. Because had it been divisible by 11, we would have had the same digits. We would have had 33, 44, 55 and so forth, because it's a 2-digit number. It's not divisible by 11. Let's move on to 13. Is 31 divisible by 13? The answer is no, because 13 times 3 is 39. That's too large, and 13 times 2 is 26. That's too small. It is not divisible by 13. The next one is 17. Is 31 divisible by 17? The answer is no. 31 is not divisible by 17, because 17 times 2 is 34. We are already above 31. That's it. We only have to go halfway mark. We don't have to go beyond that. We only have to hit the halfway mark. Half of this one. Half of this one is about 16. That's all you have to go. Because if you go to 19, if you try to divide 19 by 31 by 19, of course you're going to have 31 will go into 19 one time, and then you're going to have some remainder. You only have to go hit halfway mark. 31, it turns out, is a prime number, because we cannot divide it by we cannot divide this number by any of the other prime numbers. Let's carry on. 33, of course, is not a prime number. I'm doing this thing, of course you understand, these are very simple, but as you get in a larger number, sometimes it's difficult. Is 31 a prime number? The answer, of course, is not. 31 is not a prime number. 31 is 3 times 11. We can divide it by 3, we can divide it by 11. 35 is not a prime number. It's a multiple of 5. How about 37? Let's go very quickly. We're going to pick up speed now. Is 37 divisible by 5? The answer is, well, let's find out. We can't divide 37 by 2 because it's not an even number. We cannot divide 37 by 3 because the sum of the digit is 10, and 10 cannot be divided by 3. It's not divisible by 5 because it doesn't end in a 5 or a 0. Is it divisible by 7? Is 37 divisible by 7? The answer is no, because 7 5s are 35. 7 5s are 35, and that's just 2 more. We can't divide by 7. Is it divisible by 11? The answer is no, because had it been divisible by 11, it would have been either 33 or 44. Is it divisible by 13? 13 times 3 is 39. We just saw it. 13 times 3 is 39. We just saw that. This is 37 is 2 less than that. 13 times 2 would be 26, and this is not divisible by 13. Is it divisible by 17? 17 times 2 we just saw is 34. This is 37. It's not divisible by 17. That's it. We hit the halfway mark. It is a prime number. How about 39? 39 is very simple to figure out. It's obviously each individual digits are divisible by 3, so it's 3 times 13. That's not a prime number. How about 41? But same exact routine. Same exact routine. We can't divide 41. Can't divide 41 by 2. We cannot divide 41 by 2 because it's not an even number. We can't divide 41 by 3 because sum of the digit is 5. 5 cannot be divided by 3. We can't divide it by 5 because it doesn't end in a 0 or a 5. We can't divide it by 7 because 7 6 are 42. This is 41. Can we divide it by 11? The answer is no. 44 is divisible by 11, but 41 is not. Can we divide it by 13? 13 3s are 39. That's only 4 more. So if you divide it by 13, it's going to go 3 times, but then we're going to have a remainder of 4. We can't divide by 13. Can we divide it by 17? 17 times 2 is 34. 17 times 2 is 34. And we cannot go one more 17. It's not divisible by 17. We have to hit halfway mark. Halfway mark in this case is going to be 20. So we have to try 19. 19 times 2, where can we do it? 19 times 2 is 38. This is 41. This is only 3 more than that. 41 is only 3 more than 38. So it's not divisible by 19. It will go 2 times and we'll have a remainder of 3. 30 looks like 41 is also a prime number. That's it. We have to hit halfway mark. Let's go 43 very quickly. Now we are beginning to get the idea. 43 is not divisible by 2 because it's not an even number. It's not divisible by 3 because the sum of the digits is 7. 7 cannot be divided by 3. It's not divisible by 5 because it doesn't end in a 0 or a 5. It's not divisible by 7 because 7, 6 are 42. This is 43. It's going to have a remainder of 1. It's not divisible by 11 because this is 43, not 44. Is it divisible by 13? The answer is no, because 13 times 3 is 39. This is only 4 more than that. You're going to have a remainder of 4. Is it divisible by 17? The answer is no. 17 times 2 is 34. And if you divide this number by if you divide 43 by 17, it will have 34 two times, and then we'll have a remainder of 9. It's not divisible by 17. And of course, it's not divisible by 19 because 19 times 2 is 38. We're going to have a remainder of 5. This is also a prime number. How about 45? 45 is not a prime number, of course, because it ends in a 5. If it ends in a 5, it is divisible by 5. To say nothing of the fact that 4 plus 5 is 9, 4 plus 5 is 9, the sum of the digit is divisible by 3, therefore 45 is divisible by 3, of course. It's divisible by 3 and 5, of course. And many other numbers, as a matter of fact. 47, very quickly, it's not divisible by 2 because it's not even. 47, we can divide 47 by 2 because it's not even. We cannot divide it by 3 because 4 plus 7 is 11, and 11 is not divisible by 3. We cannot divide it by 5 because it doesn't end in a 0 or a 5. We cannot divide it by 7 because 7 sevens are 49. This is 47. We can't divide it by 11 because if we divide it by 11, it will be 44. We'll have a remainder of 3. We can't divide it by 13 because 13 times 3 is 39, and that's going to give us a remainder of 8. It doesn't divide evenly by 13. How about 17? 17 times 2 is 34. If we divide 47, we'll have a remainder of 13. It's not enough. So 17 times 3, 21, 2 is 51. This is not enough. We have 4 short. It's not divisible by 17. Is it divisible by 19? 19 times 2 is 38. We're going to have a remainder of 11. It doesn't divide by 19. And since this is 47, we have to go halfway mark, which is about 23. So we have to keep on going. The next odd number is 21. 21 is not a prime number. The one after that is 23. 23 is a prime number. And 23 times 2 is 46. 23 times 2 is 46. This is 47, which means if you were to divide 47 by 23, we'll have a remainder of 1. This number is not divisible by 23. That's it. We hit the halfway mark. It is a prime number. And 49, of course, is not a prime number because that's a perfect square. That's it. We are done. How many prime numbers are there between 30 and 50? The answer is 1, 2, 3, 4, and 5. Unless I miscount it. I count 5. There are 5 numbers. Let's see if I'm correct. 31, 37. We have 31, 37. There's 2. 41, 43. There's 4. And then 47. There are 5. There are 5 prime numbers between 30 and 50. Let's move on then. Number 45. Give me a second. So essentially we go through the same exact process in this video where we locate all the prime numbers 1 through 100. And there are a couple of them that many times people miss because they don't look like they look like prime numbers, but sometimes but it turns out they are not, or the other way around. People miss they miss the prime number, thinking that it is not a prime number. There are a couple of them. If you go 1 through 100, that give trouble to a lot of people. Make sure you know all of you. Make sure you know all your prime numbers 1 through 100. The classic one is this. I don't know why, but many a times students think that 51 is a prime number. 51 is not a prime number. It's very easy. 5 plus 1 is what? 5 plus 1 is 6. The sum of the digits of 51 is 6. Since the sum of the digits is divisible by 3, 51 is divisible by 3. How can 51 be prime numbers? The sum of the digit is 6. If you were to divide it by 3, you will get how many 3's in a 5? 5 has 1 3. 5 has 1 3. The remaining 2 goes and joins the 1, becomes 21. How many 3's in a 21? 21 has 7 3's. There you go. turns out that 51 is not a prime number. 51 is 3 times 17. 51 is 3 times 17. Similarly, there is one more in the 90s that people miss sometimes. I can't think of it right now, but there is one more that people sometimes have trouble with. Next one. Question number 45. In question number 45, we are given a triangle that looks something like this. Here is our A, B, and C. It's a right angle triangle. We are told that the hypotenuse is 2, this side is x, and this side is 4 minus x. Now I understand, I realize that in the book that's not how they draw the picture, but that's how I drew mine, because it's easier to see. And if you don't want to look at it this way, you could have also drawn it this way. It makes no difference. You can draw it your own picture. Here's your A, here's your B, here's your C. Hypotenuse is 2, this side is x, and this side is 4 minus x, so root of 4 minus x. The question is, how much is cotangent of A? Well, cotangent, as we know, tangent we know, so ka to r. Tangent we know is opposite over hypotenuse. Tangent we know is opposite over adjacent. Tangent we know is opposite over adjacent. Therefore, cotangent is going to be opposite of that, which is going to be adjacent over opposite. Adjacent over opposite. So it doesn't matter whether you draw the triangle this way or that way, you're going to get the same answer. We are interested in angle A. And the adjacent here, adjacent side to angle A here, is this side right here. This is the adjacent side. This is our adjacent side, which is root of 4 minus x. And then opposite to angle A is this side, which is x. That's it. We would have gotten the same answer had we drawn our triangle in this way. In which case, here is our point A, this is the angle we are interested in, and the adjacent side to this one is this guy right here, adjacent, and the opposite to this side is A, opposite to this side is this guy right here, x. So it's root of 4 minus x over x, which is answer choice E. I'll see you tomorrow, okay? Bye now.